buddies. It's me, Mrs.N.Nithya from the Department of Information Technology with you all from Nirmala College for Women, Coimbatore. Now, it's been always a wonder to know about our tiny little machine called computer, which is a great invention in this current era. It's been always an interesting concept how this machine is handling the various requests from the users. Here, when I say the request, it includes both the input request as well as the output request. Now, let us get into the video how this wonderful machine is handling all the requests at a time to give an accurate result to each and every user. Now, let us get introduced to the topic called disk scheduling. First, we are going to see what is disk scheduling, and next what is the structure of a disk and how we are going to schedule the disk, and compare which is the efficient algorithm for scheduling a disk, and how to select a perfect algorithm. Now, what is disk scheduling? Actually, disk scheduling is nothing but processing the multiple input-output request which is being given by the multiple users to a particular computer. And the computer has to access the multiple input-output request in an efficient way as well as in a fast accessible time, so that a particular user can receive the required output for his input or output request given. Now, who is responsible for this disk scheduling? Mainly, the operating system of a particular computer is responsible for the disk scheduling process. So, as soon as the input-output request arrives from the user to the computer, that input-output request has to be processed. So, all the input-output request cannot be processed at a time. It has to be processed, accessed, and the output has to be transferred to the user back in a sequential order. That is, one by one, each and every input-output request has to be accessed. So, this input-output request processing will be controlled by the disk controller. Now, first let us see what is the structure of a particular disk. And a particular disk will be divided into multiple segments called tracks, cylinders, and sectors. So, each and every disk will be having a combination of a component called platters. That is, each and every platter will be having two surfaces, that is front and back, and each platter will also be having two read and write heads for each of its surface, and each platter, which is arranged in a sequential way in a cylindrical form, will be having the same number of track. These platter will be made up of material called aluminium, ceramic, or glass, which will be again coated with a magnetic material called iron oxide. Now, let us see the actual view of this track, sector, and cylinder concept. This is the actual structure of a disk actually. In this, we can see each and every platter is assembled in a single spindle which is being kept vertically. Each and every platter is having a surface, and this each and every surface is connected with a arm assembly which will again is having a read-write head. So this read-write head is attached to each and every platter in a disk structure cylinder with the help of an arm. In this, each and every disk alignment will be having a track, a sector, which will again form a cylindrical portion. So each and every track of a plater will be arranged in such a way which will form a cylindrical portion. So in this, each and every track will have its own sectors. So a track is divided into sectors, and these tracks put together forms a cylindrical portion, and this cylindrical portion is connecting all the platers together, and in turn these platers are attached in a spindle. This spindle will be helping the entire structure to rotate according to the processing speed. So once it rotates in a rotational format, the read-write head which is attached to the disk will be reading the data from each and every sector of a track with the help of a read-write head attached to the disk structure. Now, what is the main process in accessing the input-output request is the scheduling time. That is, each and every request has to be processed in an efficient and fast way. So now we have to calculate which will be the efficient way to process the input-output request received from the user. So for that, we have a concept called disk scheduling. Basically, we have a concept called access time, which is the time required for the disk to access a particular record. This record will be given as an output to the user according to their input-output request. So the access time is nothing but the time required for the disk to access a particular record, which is again being saved in the sector of each and every plater. Now, we will be having generally so many datas saved in a sector, which will again form this combination of sectors will again form a track, and each and every plater will be having its own tracks. So if you want to access a particular record in a particular track of a particular sector, we have to, the disk, that is the read-write head, has to search for that particular data in a particular sector. So the time required for the disk to move the read-write head to the particular sector, the necessary sector in the disk, is called as seek time. And again, once the input-output request of a particular user is getting processed, we will be having the other request. The system will be having multiple input-output requests from the user. So in that case, the next request will have a minimum wait time. So that additional wait time for that particular disk to rotate the head to the desired sector according to the request will be called as a rotational latency. And again, we have an important concept called bandwidth. So bandwidth is the main term which decides the speed of a particular computer. So this is nothing but how many bytes, that is the data, will be, normally the data in a computer will be measured in the form of bytes. So here bandwidth is nothing but which gives a number of bytes, that is how much byte is getting transferred in a particular time period. So we can calculate the bandwidth by dividing the total number of bytes transferred by the time of last transfer subtracted from the time of first transfer. That is the time taken between the last transfer and the first transfer, and this time period will be divided by the total number of bytes transfer. So then we can get the bandwidth. Here in this picture we can able to see the representation of the disk access time, disk response time, everything. So disk access time is nothing but what we have seen already. The time taken by the disk to move its head, that is to find the particular record in a particular sector. So it is the time between the seek time plus the rotational latency plus the transfer time. That is the time taken to identify the record plus which may include the waiting time plus the time transferred to locate the data from the sector to give back to the user according to their request. This we call it as disk access time. So next is disk response time. So disk response time is nothing but according to the user's multiple input output request, each and every request will be in a queue according to the waiting time. So the time, that is the time taken for the disk to respond to the next request of a particular user. So that time will be having a bit delay sometimes according to the multiple input output request. So put together the delay time, that is the time for the particular input output request to be in a queue to get accessed, plus the seek time plus the rotational time, that is the waiting time, and the time taken to transfer the data from the sector to the user. So put together these time totally forms a disk response time. Now let us see what are all the possible algorithms to decide this multiple input output request to get processed. This concept only we are addressing here as disk scheduling. So now we are having few disk scheduling algorithms which will be utilized and used to make the hardware of a particular system very efficient. In turn, it can minimize the seek time. So each and every algorithm will be designed in such a way where it will be used to utilize the hardware of a particular computer by minimizing the seek time as much as possible. So what are all the available algorithms? Is first come first serve, shortest seek time first, scan, C-scan, look and C-look. Now let us see one by one. First come first serve, in short FCFS. So in a queue, the request which is being raised first will be served first. That is, the request which comes into the queue first will be accessed first. That we call it as first come first serve process. So according to this algorithm, first come first serve, the input output request from each and every users will be handled and processed in a sequential way. So this approach performs in a random scheduling way if it is getting many requests from the user. But this first come first serve, it mainly suffers from a zigzag effect, because if input output request is in the queue first and you are getting multiple requests, that it has to identify which request has been taken next, and after that it has to go and search which request arrives stands next in the queue. So in this process it will be traveling in a zigzag way. So normally the first come first serve algorithm, it suffers from a zigzag effect. Here we have an example through which we can easily understand the first come first serve process, that is the movement. In this we have n number of movements waiting in a queue numbered as 98, 183, 37, that is the sector positions. So here the head starts from the 53rd position. So that is the first thing. And next it moves to the next process in the queue, that is 98, and then to 183, again to 37, and again to 122, next to 14, and then to 124, and then to 65, and then to 67. Here when we look at the picture, we can able to see the zigzag movement of a head. When we normally when we check the diagram, we have number 65 next to 53 and number 67 next to 65 and number 98 next to 67. So if the head moves sequentially, first 53 has to be processed, next 65 has to be processed, next and then 67 will be processed. But here it is not getting processed in such way, that is in the plain sequential order. So it is checking which request stands next in the queue next to 53. In that case, 98 is standing next to 53. So first, after completing 53, immediately it travels to 98. Then next to 98, it immediately travels to 183. According to the request which stands in the queue, it is serving. So first come, first serve is traveling according to the request which has been standing in the queue. Next to the first came a request. So that's what we are getting a zigzag effect according to this algorithm. Next algorithm is nothing but shortest seek time first. So as per the name explains, the shortest seek time record will be taken into the processing concept first. So according to this algorithm, each and every input output request will be selected which carries the minimum seek time from the current head position. It is also called as shortest seek distance first. For example, if a head is read-write head is standing in a particular position, from that current position, it will look into the input-output request which stands nearer to its current location. So it will take that access request and then it will process that particular request. Again next, now the position which transferred from the current position to next position will become a current position, and from that position it will search for a nearer request, and then that particular request will be taken into process. Then again it will be get processed and the head will be moving from this location to that location, and again from that location it will be searching for the next nearer request. So in this way the shortest seek time first algorithm is executed. Now it will be very easy to understand in this diagram. Now the head position is 53 here. So as we look into the diagram, we can able to understand 65 is the nearer request next to 53. So next 65 will be accessed, and to 65, the 67th sector is the nearest sector. So hence it will be accessed next, and from 67th location, the next nearest location will be 37. So again it goes on according to the shortest seek time by calculating from every current position. So this is the concept of shortest seek time first. The next algorithm in hand is scan. So according to this algorithm, the disk starts from the one end and it will moves towards the other end, servicing all the requests on its way. Once it moves to the end of the other end, the arm will be reversed again, which will be servicing the request, all the requests on its way. So it will be moving in both the direction, to this end to that end. Here in this picture we can able to see clearly how it starts from 53 and it moves next to the other end until 0, then it moves to the other end, extreme end called 183. Then again it will be traveling all the way. So this is the concept of scan. Next algorithm we are having at hand is look. So look is nothing but it works in a way the disk arm starts at the first IO request on the disk and again it moves towards the last IO request on the other end, servicing all the requests until it gets to the other extreme input output request on the disk. Here the head movement will again be reversed and again the service will be continued. So it will be moving in both the direction until both the last input output request is reached. This we have another algorithm called CLOOK, which is again a look version of a screen, that is the C-scan. In this algorithm, ARM only goes as far as the last request in each direction. So then again it reverses the direction immediately. So in this algorithm, it won't go all the way to the end of the disk in which the scan works. It actually reaches the last request in one particular direction. Then again it changes the direction. Then it goes on the next direction. In this picture, we can able to see how the head moves in each and every direction and the last record of each and every direction is accessed. Again, we have an algorithm called C-scan in which the head moves from one end of the disk to the other end, servicing the request as it goes. Immediately when it reaches the other end, it returns to the beginning of the disk without servicing any request, unlike the scan. So it immediately returns to the first position. Then again it travels from that position to the extreme position. So this is the pictorial representation of a head movement of C-scan. Now, here if we compare all the algorithms together, we can able to identify which is the apt algorithm to process a particular output request. So when we look at the bottom, we have average seek time of each and every algorithm to access a particular record. According to this comparison, we have the shortest seek time first algorithm will be having the minimal seek time, that is the time taken to access a particular record. So this algorithm will be taken as a best algorithm for disk scheduling. So this shortest seek time first algorithm performs better when compared to all the other algorithms without giving a heavy load on the disk. So it will be depending upon the number and types of the request receives. So each and every request for a disk service can be influenced by the file allocation method. And again, if we go for this shortest seek time first, and it also the performance depends on the number and types of the request it receives. So the disk schedule algorithm should be written as a separate module of the operating system, which will be replaced with a different algorithm if necessary according to the number of algorithm received.
I think you all will be happy to learn about the concept called disk scheduling through this wonderful video. Thank you all.